Welcome back. In the last lecture, we have seen how the conditional sentences, especially when they are analyzed in terms of material implication, we need to face some kind of problems. We will continue with that discussion on how material implication and strict implications are not sufficient enough. Then we need to come up with a new connective that we are calling it as conditional connective. So, these are some of the examples that we have seen. One is the antecedent strengthening, law of contraposition, law of transitivity, and anything which is related to, there are various instances of paradox of material implication. So, all these things are considered to be bad validities, and whenever you come across, whenever you are trying to build a logic of conditionals, we need to ensure that all these bad validities should not be part and parcel of our system. So, here is an interesting argument which is provided by Dorothy Edgington for the proof of the existence of God, which is a funny kind of proof. It goes like this: when you define material implication A implies B as not A or B, and we need to face this particular kind of problems like this. Suppose if you say, if God does not exist, then it is not the case that if I pray and my prayers will be answered. So, if God does not exist, I do not have to pray anyone, and even if I pray, my prayers will not be answered because God does not exist. So, that is why I do not pray, not be. So, from this it follows that God exists is the case. Even if I do not pray, there is no such object kind like something like God exists, but still it leads us to believe that even if I do not pray, but still God exists, results in. So, it goes like this: if God does not exist stands for not G. Not G implies it is not the case that my prayers, if I pray and my prayers are answered, are written in this sense. Not of P implies A, and then it is further simplified into my negation of G implies P and not A, and this by definition X implies Y is not X or Y. It leads to G or P and not A, and when you substitute this sentence that I do not pray stands for P is equal to 0, I pray stands for P is equal to 1, then it leads to 0 or 0 and not A. Anything which is a conjunction of a false proposition is false. So, that is why God exists is the case, that results. So, this seems to be a little bit weird for us. It's a weird kind of conclusion that we have come up with. Even if I do not pray, my prayers are not answered, but still God exists is the case. So, this leads us to view that we need to move away from the material implication. Another example which I discussed in the last class is that whenever the antecedent of your conditional is false, especially in the case of material implication, irrespective of whether the consequent is true or false, it is going to be true. So, now this leads us to revise the semantics of conditionals. So, the examples that we have discussed so far raises a problem for the pragmatics of conditionals, and do not call for a revision of the do call for the revision of the semantics. So, that is Quine in 1950 paper on indicative conditionals, Grice on conversational implication, and Lewis' work on counterfactuals all suggest us that there need to be a revision in the semantics of the conditionals. So, the examples call there are two views which you can think about. One is no revision is required, but you can still define in terms of material implication, and the second view is that we need to have a revision of semantics of conditionals. Again Quine in 1950 on counterfactual conditionals, and Stalnaker 1968 paper on indicative conditionals, and Lewis' work on counterfactuals. So, Quine is of the view that whatever the proper analysis of the counterfactual conditionals may be, he calls it as counterfactual conditional maybe, we may be sure in advance that it cannot be truth functional at all. For obviously ordinary usage demands that some counterfactual conditions with false antecedent and false consequents be true. In the same way, there are some other kinds of counterfactual conditionals with false antecedent and false consequent may be false. So, now the problem is that how do we differentiate with respect to these two kinds of conditionals where false antecedent and false consequent leads us to believe the first set of conditionals to be true, and then false antecedent and false consequent in the second case. it is not acceptable to us. For example, if you see this example, it will be clear. If I weighed more than 150 kg, which is false anyway, nobody can weigh more than 150, or you can take 200 also, it does not matter. I would weigh more than, definitely weigh more than 100 kg, because 150 is greater than 100. So false antecedent and false consequent, especially when your actual weight is 70 kg. So if your actual weight is 70 kg, if weighed more than 150 is false, I would weigh more than 100 kg, that is also false. False antecedent and false consequent, but still it is acceptable to us. Whereas if you come to the second one, if I weighed more than 150 kg, then I would weigh less than 25 kg. So both are considered to be false, in a sense that 25 kg is less than 70 kg, in that sense it is false, and 70 is less than 150, that is why it is also false. So now the problem is that the antecedent and the consequent of both the conditionals are considered to be false, if you put it in the present tense, now at this moment. Yet the first sentence, interestingly, the first sentence is all the one which is acceptable to us, whereas if your actual weight is 70, you will not be able to accept 25 kg is your weight. It seems to be more or less will lead us to accept the first conditional, whereas when it comes to the second conditional, it is not going to be acceptable. We are not going to accept the second conditionals. So how do we analyze these two things? How do these things reflect in our semantics? That is what is of interest to Quine when in his work on counterfactual conditionals. So in the process, in order to fix the problem of material implication, C.I. Lewis has come up with strict implication. This is the one which we have extensively studied when we discussed about normal modal propositional logic. But unfortunately, the problem is that even strict implication of course solves the problem of paradox of material implication, especially when you take implication as strict implication. But when it comes to strict implication also leads to some other kinds of bad varieties, like it is still considered to be monotonic, but our day-to-day reasoning or reasoning with respect to conditionals is considered to be non-monotonic in nature. Another thing is that strict implication also suffer from paradox of strict implication. If the antecedent is considered to be strict, any kind of stage, one of the instances of paradox of strict implication is that from impossibility you can derive anything. So if you start with P and not P, you derive anything, and then a strict implication follows from any kind of strange kind of proposition. There also it remains, the paradox of strict implication remains the same thing as in the case of material implication. So this is the story with respect to material and strict implication, both are having problems. Now we need to come up with another conditional connective. So that is the one which we are trying to talk about. So now whenever you talk about any conditional statement, if P then Q, we need to take into consideration ceteris paribus clauses. To give an example is like this: if it does not rain tomorrow, we will go to the stadium to play cricket. Hence, if it does not rain tomorrow, together with that there are some kind of clauses. So usually it is understood that whenever you have a conditional sentence A implies B, so there are many ceteris paribus clauses, all other things being equal. So these are considered to be ceteris paribus clauses. A implies B means there is something A together with some kind of X leads to B. So this X is what is called as ceteris paribus clauses. So in this case, if it does not rain tomorrow, we will go to the stadium to play cricket. Hence, if it does not rain tomorrow, then something happened to me, or I met with an accident, or I broke my leg, or something like that. All other things are being equal. That means all bad things did not happen. So that's why you will go to the stadium to play cricket. So usually we don't talk about such kind of nonsense, in the sense that we make, although they are all implicit, but when you are analyzing the conditional statements, we need to ensure that we need to make these ceteris paribus clauses explicit. So what are the ceteris paribus clauses? The correct sentence for one is this thing: if it does not rain tomorrow, we will go to the stadium to play cricket. Is if it does not rain tomorrow, then all other things being equal, like somebody did not attack you from Mars, you don't take these examples into consideration. All of a sudden Earth does not spin from east to west rather than from west to east, all other things are being equal or in its place, then you will go to play cricket. So we can call all other things being equal as ceteris paribus clauses. So now conditional sentences include some notions of ceteris paribus clauses like GA together with the antecedent, and that leads to the consequent B. Usually these ceteris paribus clauses are considered to be implicitly present in the conditional, and it is assumed to be implicit. I mean, they are implicitly present in the conditional sentences. So now whenever you are coming up with the semantics of conditional sentences, we need to ensure that your semantics will take care of this ceteris paribus clauses as well. So therefore, in the example sentence, if A does not play tomorrow, then GA includes the condition that we are not invaded by so many things like nonsensical things like we are not attacked by Martians, or if flying saucers arrive from the Mars. Doesn't make any sense to talk about it, but still all other things are being equal, then this conditional holds. But these are not made explicit there. We do not explicitly talk about this ceteris paribus clauses. So if it does not rain tomorrow, we will go to the cricket. If it does not rain tomorrow, then all other things being equal, we will go to the stadium to play cricket. So that means any given conditional A implies B needs to be read like this: A together with the ceteris paribus clauses leads to B, where CA is considered to be ceteris paribus clause. Then CA might include something like we are not invaded by Martians, or your flying saucers arrive from the Mars, or any other thing like there is no friction on the Earth, friction becomes zero. All these things are not the case. Our Earth doesn't spin from east to west instead of west to east, etc. Our sun doesn't rise at all. All these things are being equal, then you will go to play the cricket, go to the stadium to play cricket. But how do we spell these ceteris paribus clauses explicitly? So we need something so that it can be reflected in our semantics. So conditionals are not easy to. It's not easy to analyze the conditional sentences because everything is dependent on the context, the way the speaker has uttered this conditional sentences. All these things matters when it comes to conditional sentences. It's not just like P implies Q. Is the truth value of P implies Q is solely determined by truth value of P, truth value of Q. It is not like that. That's the reason why we are trying to analyze whenever a truth value of a compound sentence is not determined by the truth value of its individual constituents, then we say that it is considered to be intentional. So now let us consider the syntax of the conditional logic we are going to talk about, that is C. To begin with, C is more or less like analogy of this one, could be the minimal modal logic that we have seen in the case of normal prepositional modal logic. So that is K is due to crib K. So now let us write A implies B as the conditional with the ceteris paribus condition. If A plus CA, then B. Now the syntax of conditional logic is defined in by using again Boccos normal form. It is like this: F is any atomic formula is a well-formed formula in our conditional logical system. A negation of any formula is also well-formed formula. Anything which is combined by conjunction, disjunction, implication, by implication is also considered to be well-formed formula, or anything which begins with the unary operators, necessity, possibility, etc. is also going to be the case. This is all nothing but the normal modal, prepositional modal logic. In addition to that, we have a connective. F implies F. I am reading this greater than connective as implies. Greater than is used to differentiate material implication, and on the other hand we have strict implication. So now how this ceteris paribus clauses together with the antecedent is reflected in the semantics of how ceteris paribus clauses can be reflected in the semantics of conditional logic that we are trying to come up with. So, we need to extend our formal language with the logical connective greater than that is A implies B, and then we have Kripke models W, R, V, the normal modal logical operators for the normal modal logical operators, but for the conditionals the interpretation changes a little bit. Instead of W, R, V, now we write it W, R, A. A is considered to be the antecedent of your conditional. It is not just letter A, but it is considered to be antecedent of a condition. If the antecedent is P and Q, you need to write R, P and Q. That A is A belongs to your language L, and then V is in general considered to be, as usual, it is considered to be valuation function. So, the only thing which is different here is that the accessibility relation. Accessibility relation is always with respect to the antecedent of your conditional. So, that is the main thing that you need to note. Now, so there are two things which you need to note, RA and FAW. This is the one which we will be using in the next few minutes. We will be using these things. That's why we need to be clear about what is this RA and FAW. These two can be interdefined to each other. FAW is considered to be a set of words which are accessible with respect to the antecedent of your conditional. So, that is considered to be any other word X that belongs to set of words W, such that this W is accessible to RA accessible to X. So, it is like this is FAW means you started with the word W, and then FAW is any such kind of word X. So, where this W is RA accessible to X. So, this is what is FAW. FAW is any such kind of word X such that this X belongs to set of words W, and then such that W WRA X. So, this has to be non-empty. If it is empty, if there is no word which is accessible with respect to the antecedent of your word, and the conditional is going to be vacuously true. It happens in the case of impossible kind of antecedent. If 2 plus 2 is equal to 5, Rahul Gandhi is the Prime Minister of India, for example. If you say that thing 2 plus 2 is equal to 5, there is no word which is accessible to that one. So, the antecedent is false there. Obviously, the conditional, there is no word which is accessible to the antecedent of your conditional. 2 plus 2 is equal to 5, the conditional is going to be vacuously true. So, R and F are considered to be, F will serve like some kind of selection function. It picks up the world, the nearest world which is accessible from the actual world W. So, RA and F are considered to be interdefinable. It is like this: W is accessible to another world W prime with respect to the antecedent of your conditional, if and only if this W prime has to be it belongs to whatever that FAW picks up. That FAW picks up, for example, X, then W1 belongs to X. So, both ways you can define this thing. So, now RA is considered to be collection of binary relations on W. This accessibility relation with respect to the antecedent. For example, if you say two worlds are accessible to each other with respect to the antecedent of your conditional, W1 RA W2 means that A is true in W2, which is same ceteris paribus together, it is same as W1. So, now the truth conditions for necessity of A, possibility of A is same as in the case of modal logic. So, now how do we define the semantics of possibility operator, necessity operator, and how do we know the truth conditions for a given condition? Possibility of A is true with respect to the world W for any such kind of W1 belongs to W, such that W is accessible to W prime or W1, such that A is true in that world W, any such kind of W prime. Otherwise, it is considered to be 0. And these are the things which we have defined it in the case of modal logic, and we do not have to go into the details of it. Now, a conditional sentence A implies B is true in a world W, that is what is V W A greater than B is equivalent to 1, if and only if for all such kind of W1s where this actual world W is accessible to this W1, your B has to be true. In all the antecedent permissible worlds, your consequent has to be true. In that case, you say that A implies B is true. And another notation that we will be using, that is if A is written in the brackets, that means these are said to be considered to be some of the class of worlds where A is considered to be true. If you write B there, then all the worlds in which B is considered to be true. So now the truth conditions for A and B reflecting those ceteris paribus clauses is like this. A implies B is going to be true in a world W if and only if FAW are those worlds like X or Y or any such kind of things. In those worlds, your B is true. Whatever is FAW has to be subset of those worlds in which B is true. In all the antecedent permissible worlds, your consequent also has to be true. In that case, the given conditional holds. So now how do we reflect, how do we talk about semantics of these things in terms of how these semantics can be reflected in our main method, that is semantic tableaux method. So we will be talking about the semantic tableaux method with respect to conditional logical systems C and C plus in the next class. Thank you.